Okay. So we are going to talk about transport layer. Right. Basically, we have seen that there are lot of roles and responsibilities with respect to transport layer, right? The roles and responsibilities which may include end-to-end delivery, flow control, process control, congestion control, error control, right? So a lot of responsibilities that a transport layer is having. Okay. Now in that we try to see that there are many protocols comes in transport layer. So what are those protocols we try to see? One may be like TCP, right? UDP, even we saw that SCTP, right? So a lot of protocols, basically they are meant for transport layer, right? In that, the transport layer protocol can either be connectionless or it can be connection oriented. Right? Say for example, I could say that TCP I have, it is connection oriented. We have UDP, maybe it is connectionless, right? So like that we have the transport layer protocols which can be either connectionless or it can be connection oriented. Yes, Yashwant.
Huh?
Yes,
It,
unable to hear you. You gave a missed call here.
I am.
Any problem?
No, ma'am.
Right. Shall I continue?
Yes, ma'am.
Right. Okay. So I was telling that the protocols can be connectionless or even it can be connection oriented. Now let us see about what is connectionless, right? So here in case of connectionless, packets are sent from one person to another person where there is no need of connection establishment or connection release. Okay, that means if I just consider that I have a sender, okay, and there is a receiver, right? So here in case of connectionless, the packets whatever you are sending from source to destination, okay, so there is no need of any connection establishment or connection release. So how in case of connection oriented happens? That means like if I have a sender and you have a receiver, right? So what happens? First connection has to be established, right? So first step is like establishment of the connection. So that can be done again by sending a request packet to the receiver, right? So here after a connection establishment, okay, what information, that is an acknowledgement or whatever it has been received by the receiver, okay, he will send his capacity and other informations along with the acknowledgement. Later after connection establishment, data will be sent, right? Then after all the data is been sent and informed that the last packet is received by the receiver, then the connection will be released between the sender and the receiver. Okay, but here there is no such cases. That means here we don't go for no connection establishment, right? And no connection release. Hope you are understanding, right? So we will not be having any connection establishment or connection release. And whatever the packets we are sending here, no, they are not numbered. Okay, packets are not numbered. So hope I just told you. That means if I have one frame and another frame, there are multiple frames which are to be sent. There is no dependency of the packets or the frames, whatever you will be sending. Okay, that means like if I send 1, 2, 3 in an order, okay, at the receiver end, what may happen? 2 may be reached first, right? 3 may be reached, 1 may not be reached, right? So and also there is no packet numbering. Okay, so in case of connectionless protocol, fine. And even we will not be having any acknowledgement. That means like no acknowledgement in case of connectionless protocol. Okay, but here in this case we are numbering the packets. That means packets are numbered, right? And here in case of connection oriented, we get an acknowledgement. See, acknowledgement is received for each and every packets whatever you send. Okay, and in case of connectionless service, there may be delay or there may be loss of data or they may arrive out of sequence. So such kind of what you can say problems may be arise. It's not a problem like the discontinuity of the packets may happen, that it may not reach it in a proper order, like so such cases may happen, right? So I'll write it may be like delayed or lost or in order, I mean sorry, not in order. So what you can say, it may arrive out of sequence. So such condition may happen, right? But here in this case what happens is okay, delay may be delayed. Why? Because you can say maybe because of the network delay it may happen, but first packet when you send, right, you will not be losing the packet. Why? Because if at all a packet whatever you are sending is not received by the receiver, okay, then he will retransmit it, because for each and every packet, okay, you will be having an acknowledgement. So any acknowledgement that is been received later, then only a transcender will send the data. One second. Am I audible? Yes, I could see some bad network quality here. So it is visible, right? Screen is visible and I am also audible properly, right?
Yes, ma'am.
Okay, fine. So these are some of the differences that you can see, right? So in case of connectionless, I could tell the best example is UDP, that is user datagram protocol. In case of connection oriented, we can take an example of TCP, that is transmission control protocol, and stream control transmission protocol, that is SCTP, okay, and which we will be discussing in a short while. So when we talk about the connectionless and connection oriented, we also should discuss about something like reliability, right? So which I told you in the roles and responsibilities of a transport layer. But when you say it is reliable and not reliable, that means, okay, let me write reliable versus unreliable. So when do you say it is reliable and unreliable? See, the transport layer service, either it can be reliable or it can be unreliable also, correct? So if at all the application layer program needs the reliability, then we use a reliable transport layer protocol. By probably you may implement flow and error control, okay, and also you ask for the acknowledgement and you tell that the transport layer is quite reliable. Okay, that means like it means a slower and more complex service reliability, because what you can tell is, see, if you want a reliable thing, maybe you have to trade off certain other parameters, right? But if at all the case of unreliability, in case of unreliability, like where I does not require, okay, whenever I don't want reliability, okay, do not require the reliability, so that condition I can choose the unreliable protocol. Okay, so in case if the application layer or the application program does not require any reliability, then I can choose this kind of protocol where it uses its own flow and error control mechanism, or you can say that it needs some faster service. Okay, so I want some faster service, and I let me not bother about the reliability. In that situation I can choose the unreliable protocols. Okay, so in the transport layer, or especially in the internet, there are three common different protocols we know, that is TCP, SCTP, right, and UDP. Now these three protocols, whatever we know, they basically they are the major protocols. Okay, let me write it. Say if at all I write the position of these protocols, okay, you call this as application layer, and this is the transport layer, right? Let me call the network layer data link layer. Okay, so in the application layer I can tell we have SMTP, simple mail transfer protocol, FTP, right, and what else you can have, CBR, right, and blah blah, like you have bootp is there, bootstrap protocol, okay, SNMP is there, fine. So all these many protocols are there. Likewise, in case of transport layer protocol, the major protocols what we have is like right now it says CTP, TCP, and UDP. So these are the three protocols, right? In case of network layer, we have something like IGMP, okay, ICMP, like internet protocol, IP, okay, and some of the connectivity between data link layer we have ARP, okay, and even RARP is there, RARP, RARP. So I think these things you might have studied earlier. We are not going to talk all these things. Data link layer, yeah, ARP will also come in between network layer and the data link layer. So this data link layer and the physical layer, basically we talk about the some of the concepts related to like LAN or WAN technology. Okay, so no protocol will discuss much here, right? So in case of physical and the data, when we know that these are the three major protocols of your transport layer, okay, so let me take up in starting as your TCP itself, right? So when I tell about the TCP has its own major roles, right? So what are the major roles of TCP that you know? Can anybody? Yes, can anybody tell me what are the major roles of TCP? No? Pardon?
Process to process communication.
Yes, okay. Apart from that, see, I'm talking about TCP here. Transport layer, TCP comes in transport layer. Okay. So one of the protocol we are discussing here, TCP, Transmission Control Protocol. So it is used in the transport layer, right? So what happens in the transport layer, whatever the information that it has been received from the upper layer, that is the application layer, it tries to take that data, adds its own header and the trailer, forwards it to the below layer, right? So that I mean, who is doing all this work? Like some, it makes use of some of the protocols, right? So that protocol, in that protocol we have TCP, and we know what basically we are talking about. Protocol is like a rules or the agreement or some set of methodologies that both the sender and the receiver should follow, right? So when I talk about TCP, it has its own roles like byte streaming. So what is byte streaming? Say for example, application layer, I have an application layer here, okay, and he is sending the data unlimitedly to the transport layer, right? So what happens, unlimited data whatever he is sending has to be now streamed, okay. So byte streaming is segmenting, a concept like we call it as segmentation. So these TCP segments, uh, basically whatever the data which is received from the application layer, okay. So each segment if I call, right, it comprises of a group of a set of bytes, and each bytes are numbered, right? Each bytes are numbered. If I consider this is like 1000, okay, and this is like 1100, okay. So the total segment is having like 100 bytes, okay. So what happens is like byte streaming, you have to byte, that means byte stream the particular information, okay, in the form of a segments, right? So that is nothing but your byte streaming. But in case of network layer, it uses like IP is basically connectionless and it is unreliable, but TCP gives that kind of connection orientation, and TCP gives like guarantee, it gives a guarantee for the data whatever you have sent to the destination, okay. So guarantee is because like it is connection oriented, right? So basically TCP is a connection oriented protocol, and definitely it gives a full duplex, right? That means both can send and receive simultaneously. And we have something called as piggybacking. What is piggybacking?
ಸ್ಯಾನಿಟೈಸರ್ ಮಾಡಿಸಿದ
ಸ್ಯಾನಿಟೈಸ್ ಮಾಡಿಸಿ
ಮಾಡ್ತಾ ಇದ್ದಾರೆ.
ಹಾಂ ಮಾಡಿಸಿ. Just a second. Please hold on for a minute. Yes. Am I audible now? So I was just telling about like TCP, right? So when I talk about TCP, I told you some of the responsibilities like byte streaming, connection oriented, full duplex, right? And one more, I just told you that piggybacking, right? So have I told you about piggybacking? Hope you people know it or not. What is piggybacking? Yes? People please respond. ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? Is it, am I audible to you people? Somebody, I think 38 members are there. Please, somebody should respond, right? Otherwise, I will not be knowing whether you people are sleeping or have kept your phone or laptop somewhere and doing some work. Also, please, somebody respond.
Yes, ma'am.
Voice is breaking. Is my voice is audible now?
Yes, ma'am. Your
Yes,
voice is
ma'am.
audible.
Yeah, because ನೆಟ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ ನನಗೆ ಹೇಳಿ ಗೊತ್ತಾಗೋದಿಲ್ಲ ನನಗೆ ಪ್ಲೀಸ್ ಓಕೆ ನೀವು ಯಾರು ರೆಸ್ಪಾಂಡ್ ಮಾಡಲಿಲ್ಲ ಯಾರು ಒಬ್ಬರಾದ್ರೂ ರೆಸ್ಪಾಂಡ್ ಮಾಡಲಿಲ್ಲ ಅಂದರೆ ಇಟ್ ಇಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಯಾ ಪ್ಲೀಸ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಸುಮ್ಮನೆ ನಾನೇನೋ ಹೇಳ್ಕೊಂಡು ಹೋಗ್ತಾ ಇದ್ರೆ ಏನು ಅರ್ಥ ಇರಲ್ಲ ಅಷ್ಟೇ ಕೇಳಿಸ್ಕೊಳ್ಳೋರಿಲ್ಲ ಇಟ್ ಬಿಕಮ್ಸ್ ಲೈಕ್ ಒನ್ ವೇ ಕಮ್ಯುನಿಕೇಶನ್ ಇಫ್ ಯು ಡೋಂಟ್ ರೆಸ್ಪಾಂಡ್ ಕ್ಲಾಸಲ್ಲಿ ಮಾತಾಡಬೇಡಿ ಅಂದ್ರೂ ಮಾತಾಡ್ತಾ ಇರ್ತೀರಾ ಇಲ್ಲಿ ಮಾತಾಡಿ ಅಂದ್ರೂ ಮಾತಾಡೋದಿಲ್ಲ ಸೀದಾ ಕಾಂಟ್ರಾಡಿಕ್ಟರಿ ಥಿಂಗ್ಸ್ ವಿ ಆರ್ ಸೀಯಿಂಗ್ ಐ ಮೀನ್ ಕಾಂಟ್ರಾಸ್ಟ್ ಥಿಂಗ್ಸ್ so piggybacking, so we are talking about the TCP roles. Okay, so here I told you about one of the role is piggybacking, right? So piggybacking, what happens is, in case of piggybacking, just let me consider that I have a transmitter, okay, and this is the receiver. Okay, so what happens is whenever a transmitter sends the information, okay, so let me tell that data is transmitted to the receiver. Now in case of TCP, we know it is a connection oriented protocol. It has to be receive, I mean it has to receive the acknowledgement for whatever the data it is sent. Agree? So what happens is, in case of piggybacking, in order to reduce, okay, the load of network, in order to reduce the network load, fine, the acknowledgement whenever it has been sent, while sending the acknowledgement, okay, along with the acknowledgement, the receiver will add some data, right? So along with the acknowledgement, because I told you, no, the transmitter and the receiver will perform duplex communication, right? So duplex means sender will also send information to the receiver, simultaneously receiver may also send the information to the transmitter, correct? So in such situation, only acknowledgement when it is sending, then again sending, see first it will send the acknowledgement, second time it should send the data, correct, no? So it is, you are making burden to the network, or you are increasing the load of your network, correct? So in such situation, what you can do is, you add some information, okay, and inform the sender that along with the acknowledgement I am also sending some part of data, okay. So in that way, if you are sending acknowledgement plus data, you are piggybacking, that is back, you are sending the data along with your acknowledgement, okay, because acknowledgement you will be sending for say packet 1, right? So that will be intimated to the transmitter. Transmitter will definitely, he will receive and he will analyze that whatever the acknowledgement he is received for the respective packet, and also he will take the data, he will whatever the data has been sent from the receiver, he will take it and he will acknowledge, okay, for whatever the data sent by the receiver, right? So that is what is called as piggybacking. So in order to reduce the network load, along with the acknowledgement, some additional information or data is sent back to the transmitter, okay, so which is called as piggybacking. And also we have TCP, which does the error control. Next we have flow control, and also congestion control, right? So a lot of, I mean, very good advantages that you can see in case of TCP, right? And I just told you that it basically makes use of three-way handshaking, right? So what is a three-way handshaking? Transmitter will first send a request to the receiver, then receiver will send the acknowledgement saying that is free enough and you can send receive the data, and transmitter will send the place the data over the channel, correct, no? So like this basically the transmission would happen. So that is what in case of TCP basically we talk about the three-way handshaking happens, okay. And some of the services also we have discussed with respect to the TCP. And when I talk about the well-known ports, okay, which are used by the TCP, let me tell you. See, with respect to TCP, right, we know what is a port, right? Port and port numbers, which we have already discussed in the previous class. And we also know some of the types of ports, right? And in that we have something called as well-known ports, right? So these are the well-known ports which are used by TCP. Say for example, what are the well-known ports? You can call it as FTP, right? And we have telnet, right? HTTP, and we have echo, okay, we have daytime, right? And RPC, remote procedure call. I think basic whatever that you can have SMTP, mail transfer protocol, then even DNS, right? Domain name system. Uh, what else you have? Different ports, well-known ports connected to the application layer. DNS. Then we have something called as Chargen also is there, Coat is there, right? So many are there actually. But I think I could remember and recall only so much, right? So I think these are some of the well-known ports, and we have a specific port number for this. Say for example, FTP, I know it is like port number is 20, right? Telnet we have a port number is like 23. SMTP, HTTP is 80 port number. SMTP like we have 25, okay, and Bootstrap, I think somewhere around it comes. Yeah, BootP is also there. BootP is not happy. Okay, BootP protocol. I think BootP comes somewhere around 67 or 65, something 67 basically. Okay, there are different port numbers which are allocated. Okay, so I think how many of you know about a few protocols, at least whatever I have listed here? Probably you will be knowing SMTP, Simple Mail Transfer Protocol, and HTTP, that is what is that, Hypertext Transfer Protocol, right? FTP, because you are using now, you will be knowing what is FTP, File Transfer Protocol. Telnet, I think most of you are familiar with terminal network, right? And probably you'll be using even echo also, that is echoes received datagram back to the sender, right? So daytime also it returns the date and time. Almost all your systems like this TCPs use daytime port, okay, and RPC, remote procedure call also will be there. And internally you will not be analyzing the application software how it is working with all these ports, right? But all these things, at least few you can remember. Domain name systems, like when you enter your website you will give the domain names so that it directly connects to the IP, right? So domain name, what happens if I give www.gmail.com, okay, it converts this domain name system directly to the respective IP address. Okay, it will reach the respective IP. So like that, even you have something called as um, a lot of protocols which I'm unable to recall. Okay, fine. But still, I think these are quite more sufficient. Some of the well-known protocols, okay, which are used by the TCP, right? Any doubt in this? Any doubt? Okay. So let me continue because I'm not getting any response from your end. So as I was telling that in case of TCP connection, we know basically TCP is what? It's a connection oriented, correct? So when we know that TCP is a connection oriented, okay. So this kind of connection oriented protocols, they try to establish a virtual path. Okay, a virtual path will be created between source and the destination. Okay, that means like all the segments which is segments which is being received from the application layer, or you can say that I have a lengthy message, right? This is my total message which my message is segmented now, like I have lot of segments, correct? Okay, so all these segments which is belonging to the specific message, if I tell, Fine. They are sent over the virtual path from source to destination. Okay. Now using a single virtual path for the entire message, basically sometimes what happens, it though it facilitates the acknowledgement process, okay, there may be a requirement of retransmission of some of the damaged or lost frames. Okay, so you may wonder like how this TCP will use the services of IP, okay, or a connectionless protocol. Sometimes like we know it is connection oriented, like how it uses the services, fine, and sometimes like you can also be aware of the TCP connection. Okay, it is definitely though we talk it is connection oriented, it is not physical, right? I am not talking about something like any physical connectivity between the source and destination. It is completely, you can call it as a virtual connection, right? It is a virtual connection. So TCP normally it operates at a higher level, right? When I tell about the operation of a TCP, it operates at a higher level where this basically TCP, it uses the services of IP. That is the below layer. ಹೆಂಗಿರುತ್ತೆ ಅಂದರೆ ಈಗ ಇದು ಟ್ರಾನ್ಸ್ಪೋರ್ಟ್ ಲೇಯರು, ಇದು ಅಪ್ಲಿಕೇಶನ್ ಲೇಯರು, ಆಯಿತಾ, ಇದು ನೆಟ್ವರ್ಕ್ ಲೇಯರು. ಈ ಟ್ರಾನ್ಸ್ಪೋರ್ಟ್ ಲೇಯರು ನೆಟ್ವರ್ಕ್ ಲೇಯರಿಂದ ಸರ್ವಿಸ್ನ ತಗೊಳುತ್ತೆ, ಓಕೆ, ಆ್ಯಂಡ್ ಅಪ್ಲಿಕೇಶನ್ ಲೇಯರ್ಗೆ ಸರ್ವಿಸ್ ಕೊಡುತ್ತೆ. I hope you are getting. Fine. That means TCP uses the services of IP basically to deliver the individual segment. Okay, to deliver the segments. Fine. At the same time what happens, it tries to serve the application layer. Okay, that means because application layer once it sends the messages to the transport layer should work to the messages whatever is been like sent from the application layer will unlimitedly send the data. Okay, this fellow will send the data unlimitedly to the transport layer. Who is doing all other processes? Transport layer. Similarly, transport layer will he will send some data. Who is doing processes for him? Who is helping him? Network layer, correct? No. So basically it uses the services of IP and provides a service for the application layer. Okay, say for example, I'll consider sometimes like if a segment is lost, consider that if a segment is lost, or you can call it as sometimes corrupted. Okay, so that time the data is retransmitted, right? Okay, so that is why like you call it as connection oriented, because for everything you get an acknowledgement, because like unlike your IP is completely like connectionless. Okay, and IP is like he will never be aware of the retransmission. Only TCP knows. Okay, and some cases like if a segment arrives out of order. Okay, what happens? Your TCP will hold. Okay, that means this is my receiver end. If I consider, okay, I have a receiver buffer, right? Buffer is there. Sometimes whatever the information 1 2 3, okay, 4 5 6 should be received, but I may not get the 4 5, I may get 6, I may get the information like 6 7. What it does, all these values will be like stored in the buffer location, but 4 5 is not received, right? So until it receives the 4 5 package, okay, it will not send it to the upper layers. Okay, so that is what is connection oriented. And here in case of connection oriented, it requires 3 phases. Okay, as I told you in the previously, the connection oriented, if I tell about connection oriented, okay, first connection should be established, then data transfer, then connection termination, correct? No, and in that connection establishment, first one is I told connection establishment. So how basically the connection is established? So we know that TCP will transmit the data in the full duplex mode. Correct, no? When two TCPs of two different machines, let me consider two different machines. Okay, they are connected. When they are connected, okay, they are able to, like, they can send the segments to each other simultaneously, again, because we are telling about it is a full duplex. Simultaneously both can send, right? So basically this implies that each of the machine, like each party, they have to initialize the communication and they have to get the approval from the other party before they transfer some data. Correct, no? That means if I want to send, say for example, Priyanka is there here, okay, and yeah, Pushpa is there here, fine. So whenever they want to send the data simultaneously, both has to take the approval from the other parties. Okay, so in case of three-way handshaking, fine, here the connection establishment is called three-way handshaking. That is especially in case of TCP, right? So I'll write TCP takes care of this three-way handshaking. Okay, so if at all I take an example, an application program called a client is there. Okay, so client application program, he wants to make a connection to the another program. Okay, I'll take it as server, another application program. Okay, they use as the TCP as the transport control protocol. Fine. So what happens? The process, it starts with the server. Okay, that means server program, he will tell its TCP to the what client. Okay, so that he will tell that it is ready to accept the connection, right? Okay, first he will tell he is ready, and that is called as a request for a passive open. Fine, so we are talking about a request for a passive open. Okay, though the server TCP is ready to accept any connection from any machine in the world, okay, it cannot make the connection itself, right? So it cannot definitely make any connection to itself. It can make connection to anybody else in the entire world, right? And the client program, he issues a request, correct, no? He issues a request for an active open. See, this is an active open and this is a passive open. I repeat once again, passive open is a request. Fine, whenever a server tells its TCP that it is ready to accept the connection. Okay, that is passive open. When I talk about active open, here the client program issues a request for an active open. Okay, and a client, if at all like he wishes to connect to the open server, he tells the TCP now that it needs to be connected to a particular server. Okay, that time TCP will start the three-way handshaking process. Hope you are understanding. Both will be having the TCP, client TCP and server TCP. ಓಕೆ, ಈಗ ನಾನು ಕ್ಲೈಂಟ್ ಟು ಸರ್ವರ್ ಕಮ್ಯುನಿಕೇಷನ್ ಆಗಬೇಕಂತಂದರೆ ಕ್ಲೈಂಟ್ ಟಿ ಸಿ ಪಿಗೆ ಹೇಳಬೇಕು ಏನಂತ, ನಾನು ಕನೆಕ್ಷನ್ ಮಾಡ್ಕೋಬೇಕು ಅಂತ, ರಿಕ್ವೆಸ್ಟ್ ಕಳಿಸು ಅಂತ. ಸರ್ವರು ಟಿ ಸಿ ಪಿಗೆ ಹೇಳಬೇಕು, ಅದ್ರ ಲೇಯರ್ಗೆ ಏನಂತ ಹೇಳಬೇಕು, that means for the request whatever you have sent, I am ready to accept the connection, right? So that then the TCP will communicate. Hope you are understanding. Fine. So we something called as passive open and active open. That is how like three-way handshaking still again it is there. We'll discuss about. Now we'll start that three-way handshaking process. Okay. The picture somewhat I'll write it here. If I call this is the client, okay, and I'll write this is server. Okay, so this is the client and this is a server. Fine. So I'll write here it is active open. Okay, with respect to the time. and this side I'll write passive open, that is also with respect to the time. Fine. So I have a client, I have a server. Here client sends the first segment. Okay. So at an instant of time, fine, he will send the first request. Okay. So the request packet, I cannot write it here exactly clearly because internally you will be having the, if you remember, SYN flag, SYN flag, right, and sequence number I'll tell it is something like 8000 or 800. Okay, and some other flags. Okay, very badly I'm writing, I don't know whether it is seen or not properly. So first of all, a client sends the first segment, like I'll tell you, know, the SYN segment, okay, in which basically SYN flag is set. Fine. So this segment is only for synchronization of sequence numbers. Okay. So it basically consumes like one sequence number, any sequence number, and that is again based on your TCP, right? Because the TCP, you can take 2 power m number of sequence number are there, and the range of it is 2 power m minus 1, right? So within that range, okay, he can choose any random number. ಈಗ ನಾನು ಎಲ್ಲಿ ಬೇಕಾದ್ರೂ random number ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀನಿ ಟಿ ಸಿ ಪಿನಲ್ಲಿ 1000 ಅಂತ ತಗೊಂತೀನಿ. ಆ 1000 ಇಂದ I'll give the continuation number 1001, 1002, 1003, 1004. So but initially what is the sequence number that you are choosing, that is like random. Hope you are understanding. Okay. So by keeping that sequence number, it takes that one of the sequence number. Okay. When the data transfer starts, fine, the sequence number is incremented by 1. Keep in mind, initially you will set the sequence number. Okay. When actually data transfer starts, no, that time the sequence number will be incremented to 1. Okay. And say that if I tell that the SYN segment carries um, sometimes no real data at all. Okay, but still we can think of it containing some imaginary byte called as 1. Fine. So that is the case. That means a SYN segment cannot carry data, but it consumes one sequence number. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಅಂದ್ರೆ ಸಿನ್ ಫ್ಲಾಗ್ ಅಂತ ನಾನು ಆಕ್ಟಿವೇಟ್ ಮಾಡಿರ್ತೀನಿ. ಸಿನ್ ಫ್ಲಾಗ್ ಇಸ್ 1 ಬಿಕಾಸ್ ಟು ಸಿಂಕ್ರನೈಸ್. ಬಟ್ ನಾನು ಸೀಕ್ವೆನ್ಸ್ ನಂಬರ್ ಏನು ಕೊಟ್ಟಿರ್ತೀನಿ, ಈಗ 8000 ಅಂತ ಕೊಟ್ಟಿರ್ತೀನಿ, ಆಯ್ತಾ? ಬಟ್ ಡಾಟಾ ಕಳಿಸ್ಬೇಕಾದ್ರೆ 8001 ಅಂತ ಮಾಡಬೇಕು. ಬಿಕಾಸ್ ದ ಸಿನ್ ಸೆಗ್ಮೆಂಟ್ ಇಟ್ ಸೆಲ್ಫ್, though it is not carrying any data, it consumes one imaginary byte. I hope you understood. Okay. So second, after you send the what you can say, the first step is like first phase we have sent the request. Okay. Second time, like server. Okay, here server at some particular instant he will try to send the second segment, okay, to the client. Fine. The second segment, it again comprises of the sequence number of his TCP, then acknowledgement number for like 8001. Okay. And synchronization SYN flag along with the acknowledgement flag high. Okay. So he will send it to the client. Fine. That means SYN flag plus the acknowledgement segment with 2 flag bits set. Okay. And this segment has dual purpose here. That means it is a SYN segment for communication, and also serves as the acknowledgement for the request, whatever this it is sent by the like it is received by the client. Okay. So a SYN plus acknowledgement, it cannot carry the data, but it consumes one more sequence number. Okay. That is why you are talking about acknowledgement is 8001. Okay. Illi ಕಳಿಸಬೇಕಾದ್ರೆ 1 byte it will consume. When it is sending back from the server to the client, again it is consuming one imaginary byte. Okay. And third step is, once the acknowledgement is received by the client, okay, the client, he will send the third segment. Hello. Hello.
Yes, ma'am. Yes, ma'am.
Yes.
Yes, ma'am.
Yes. Okay. Yeah. Lastly, I'll just finish up this particular part. So after packet is like a request, sorry, acknowledgement packet is received by the client. Okay, the client will send the third segment. That means in case if he is carrying some information, okay, that information and acknowledgement for data if he has received by the server again. Fine. So an acknowledgement segment, though that it is not carrying any data, in case some cases what happens, acknowledgement may carry data like piggybacking I said, no. So if at all carrying data, it takes up the respective sequence number. But if no data, if acknowledgement is not carrying any data, again like we cannot tell that it consumes a sequence number. Only acknowledgement, no consumption of the sequence number. But if at all it is carrying some data, it consumes the sequence number. Again, that is additional 1 byte will be consumed. Okay. So
Ma'am,
this
your
is how
voice is
basic.
breaking, ma'am.
Oh, okay. Fine. So far, whatever has been discussed is it was audible.
Yes, ma'am.
Yes, ma'am.
Okay. So I think you have to join for another class. I'll just wind up for timing now. Okay. We'll take up the attendance. Kindly answer your attendance.